Hello, thank you for checking out my video, and today we're taking a look at exponential functions, and we're working with growth and decay. So you got two formulas. You got one for growth and you got one for decay, and you got some important elements from for each formula here, and they're the same. So you've got the A, the R, and the X, and the X sometimes could just be a T. Okay, so it's going to usually represent the time. Okay, now, so what you want to do is get these three elements out of your word problem and figure out, is it going up or is it going down? If it's going up, you want to use the growth, and if it's going down, you want to use decay. So let's take a look at the first example. Alright, so here it says you've got $3,600 is placed in the account with an annual interest rate of 9%. How much will be in the account after 25 years? So, first question you want to ask yourself, is it going up or going down? Well, if you put money in a savings account and it's gaining interest, then it's going up. So we're going to use the growth formula. Okay, so I'm going to come back up here and write that down, the growth formula. And that is Y is equal to A1 plus R times X. Okay, and now all I need to do is find out what A is, what R is, and what X is. Okay, so let's see if I can use some different colors here. So A is the initial amount before measuring growth or decay. So the initial amount before measuring growth or decay is here. We start off with $3,600. So A is equal to 3,600. Alright. The next part here is the rate, and that's always often in percent. Okay, so you got the percent here, 9%. So R is equal to 9%, and you want to change that into a decimal. So you're going to move that decimal 2 places to the left. So that's going to get you to be 0.09%. Always 2 decimals to the left. Not 0.09%, just 0.09. It's 9%, and we're going to change it to 0.09. Alright, and that's the rate we're going to use. Alright, and then finally, the number of time intervals that have passed. So it says in 25 years, and it's done annually. And in a future video, I'm going to really stress this right here. But since it's done annually, it's done 25 times. So the number of times that happens is 25. So X is equal to 25. Now, the only thing you got to do now is plug each one of those things in here. So A is 36. Let's see if I can find a better place to write it. Let me write it down here. So A is 36. So I got Y is equal to 3,600 or 3,600 times 1 from the formula plus R, which is 0.09, and X raised to the 25. And all you have to do is type in this into the calculator and get your answer. Alright, so if you type this into the calculator, just like that, 3,600 parentheses 1 plus 0.09 close parentheses, and don't forget to raise it up to the 25, you'll get this number here. And they want us to round to the nearest cent, so you got to take a look at the number after the cent, and if it is 5 or higher, raise it, and if it's 4 or less, leave it alone. So you leave it alone. So your answer is going to be $31,043.09. So this is your final answer. Don't forget to pay attention to how you round it. It might be a whole number, it might be to the 10th, it might be to the cent, but you have to round it correctly. And that's growth. Alright, now let's take a look at a decay. Okay, if you want to pause the video and try to do decay, you can right here and right now. Alright, let's take a look at decay. So decay has a different formula. The decay is minus, and I told you it was decay, but let's take a look and see why. Alright, it says an element which passes 780 grams decays. It's pretty easy when it says decays, right? But sometimes you got to pay attention. It might have a different word like depreciate, okay, or declines. You got to look for the word. So if it says decay, depreciate, decline, something like that, then you're going to use the decay formula. And the decay formula is y is equal to a times 1 minus r. And that's the only difference between the formulas. Now the next thing you want to do is find out what a is, what r is, and what x is. Alright, so the element with a mass of 780 grams decays. So we know you got 780 at a rate of 17.1%, and it does it every 19 minutes. Alright, so we're going to change this over to percent here. So it's going to be 17.1, and we're going to move that decimal 2 places to the left. So that's going to make it 0.171. Alright, so now we'll type everything into the formula. Alright, so the formula would be y is equal to a 780 times 1 minus r 0.171, and don't use this here. You want to make sure you use this here after you change it over, and then raise it to the 19. And then all you got to do next is type this part into the calculator. And when you type into the calculator, it looks like this. Alright, and you get this big long number. But we want to round it to the nearest gram, 1/10 of a gram. So 1/10 is right here. Okay? And we're going to look to the number next to it, and it's 1. Now if this was 5 or higher, you would make this 22.2, but it is 4 or lower, so we're going to leave it at 22.1. And that's my final answer. Alright, again, thank you for checking out my video, and this is exponential functions, growth and decay. See you next time.